Okay? This is Hindustan Times. And then I gave a interview for Star News. I was told if I did this interview, I'd be thrown in jail. And at that moment, I thought about my grandparents. Because I realized that if I didn't say something, who would? You follow what I'm saying? I mean, how much more money do you need to make? How much more, degrees do you want to have? So I gave this interview. It hit prime time. And then shortly thereafter, I took a train up to the Nepal border, crossed it, went to Kathmandu, Qatar, and I came home. All true. Sounds like a movie, right? When I landed in Boston, I had an email from Nature India's editor. Do you know Nature? Nature is the most eminent science magazine in the world. And they said, Dr. Ayyadurai, we've been watching this organization for 70 years, and it hasn't produced anything. In fact, it produced $2 million in revenue from innovations over 70 years, which is only about 10 lakhs per year over 70 years. So I wrote an article which said innovation demands freedom. And I talked about what I'd observed, what India needs to do, and I said I'll even have an open discussion. The article got published. The Prime Minister's office put pressure on the Nature India's editor, threatened her, and the article vanished. Now, PM Bhargava, who's one of the most eminent scientists in the Indian science organization, he wrote to Manmohan Singh and said, Shiva, you should meet with Shiva. This is an excellent report. It's what India needs. And this is his article that he wrote directly to the PM. Obviously, the Prime Minister never met with me. But you see, what I had learned was exposing what occurred at CSIR was not something I wanted to do, but I had to do. Because part of being a scientist, if you look at the great rishis of India, they were actually scientists, right? Science is not just about sitting in a lab and writing about something. It's about what? It's about truth. It's about the exposition of truth. And, a carpenter gets paid to, make a house, right? A mechanic gets paid to fix a car. But a scientist is supposed to expose the truth. So to me, whether I'm researching something on Ayurveda or at the molecular level, sharing this is just truth. And this is actually a picture of me, by the way, burning the South African flag on the steps of MIT when I was 17 years old, because MIT had investments in South Africa. This is a picture of me challenging the president of MIT. Right, so that 17-year-old kid not only was an inventor, but he had a sense of social conscience. And that's a picture of me making sure when a friend of mine was jailed by the brutal Sri Lankan government that we got him out. And that's a picture of me at my MIT graduation because America had invaded Iraq, asking for, demanding the U.S. get out of Iraq. Half of the audience booed me and the other half gave me a standing ovation. My point is this, that when you're into truth, you have to go all the way. It's not just you do it in one profession and then you go home and you do something else. So when all this stuff occurred with the email stuff, it took me a while to also put on my hat, because all throughout my life, not only was I an inventor, but I was also fighting for other people's rights. You see, at MIT, they had very few black students, very few women. I also made sure that they got more women, more black students coming in. But when the attacks took place on me, I had to now become an activist and not defend me, but I had to defend that 14-year-old boy who invented email. Do you understand what I'm saying? It had to be the exposition of that truth. So we created a site called Inventor of Email, and we started actually sharing the truth. And in fact, in the middle of this, we found, that's why I believe there's a God. I don't know about gurus and yogis, but I do believe in a God, directly. One of my students found this document. This guy, David Crocker, who, by the way, was a pro-Raytheon guy, getting back to the corruption, he was acting as though he's some unbiased guy. He forgot in 1977 he wrote this document. Can you read it? Can you see this? I'll read it to you. It says, so he's writing this in December 1977. When did I invent email? 1978. So he's writing, at this time, no attempt is being made to emulate the full-scale inter-organizational mail system. The fact that the system is intended for use in various contexts and by users of differing expertise makes it almost impossible to build such a system. You see, these old white guys, frankly, who are working with lots of funding, had concluded it was impossible to build email. But that 14-year-old boy didn't, because I was literally working with these secretaries, and my job was not to just exchange text messages. I wanted to free that secretary so they could move from the typewriter to the terminal. You understand what I'm saying? That's what email is. Email was a revolutionary force because it opened up computing to ordinary people. It wasn't just about sending messages around, but it broke this huge barrier. And these people thought it impossible because they never thought that a secretary could use a computer. Okay? And then after this came out, some of you may know who Noam Chomsky is. He's one of the biggest professors at MIT. He weighed in and he said, look, it's black and white who invented email. The facts are, in fact, black and white on many levels. Now, what's fascinating is, about last year, this book comes out. It's called The Innovators. In the middle of this quote-unquote controversy, because frankly, there is no controversy, the facts, in fact, those in power sometimes create a controversy. This book comes out. I want you to look at this very carefully. I want to see what pattern you see. This book is about the innovators of the digital revolution. Okay? It's a book talking about who are the innovators. So what do you see in this book? These are the people that the book highlights. You know what that is? That's Shockley, who invented the transistor. You see anything common about these pictures? Yeah. Even a white woman's also allowed, by the way. And you know who this guy is? He was a former president of MIT. His name is Vannevar Bush. He was the one who founded Raytheon. Interesting, right? So this book suddenly comes out praising all of these people. So the education I want you to leave with today, and then we're going to move on to the Back to the Future part. You see, you may have never heard of this term, but if you haven't, you will today. It's called the Military Academic Industrial Complex. Have you ever heard of this? Okay, when President Eisenhower left office in 1960, he warned the world. He said, this is the President of the United States. He said, you must be extremely concerned, and there's a dangerous force building in the world. He said it's a military academic industrial complex. And what he was talking about was this. He was talking about the Pentagon, one part of this, big institutions, major institutions including MIT, and then the other part of those huge industries. And he said this triangle is a huge threat to humanity. And why did he say that? He was saying that this triangle tries to own innovation. You see, innovation is $1 trillion industry. And in that triangle, you'll find essentially them telling us what's an innovation. That anything that comes out of that triangle is an innovation. You see, when I was at MIT, I was on the front page of MIT 3 times because I was a good minority. You see what I'm saying? A good worker. Meaning when I invented email, when I did Cytosoft System Cell, I'm on the front page. But the picture of this boy cannot be in that triangle, right? Because you break the narrative. Because the innovation there was done outside of that triangle. It was done before MIT. Are you following me? So you need to understand this. So as you unravel this story, a beautiful education comes out of it, that you realize that what occurred to us as Indians, what occurred to that 14-year-old boy, was something much more deeper. If you haven't seen this movie, by the way, you should get a copy of it and you should see it. It's called The Inside Job. It's by a guy called Charles Ferguson. You know, in 2009, the entire economy crashed in the United States. Are you guys aware of that? And what happened was this professor, in this movie, he interviews this professor. And I'll tell you who he is shortly, but that professor wrote this beautiful scientific article. Can you read it? It says, Financial Stability in Iceland. Everyone know where Iceland is? Okay, so Iceland is, and what happened was because of this professor's writing of this article, billions of dollars got invested in Iceland. And what happened? Iceland collapsed. The economy was very unstable. In fact, this collapse took place 2 months after this article came. And it turns out in this movie, this professor got paid by the Icelandic government to write this paper. Okay? So the movie's about how academics, those in power, get paid to write history, get paid to do science. Another example is this. You know, for 50 years, we were told that smoking was good for you. Scientists were actually paid. In fact, this is an article called The Golden Holocaust. It talks about for 50 years how federal funding went to institutions. Those institutions did research to show that smoking was good. And then the other example is Galileo, right? Everyone know the story of Galileo? He had clear evidence the sun was the center of the universe. And what happened? He was vilified and thrown in prison. And it was only in 1992 did the Catholic Church say that they were sorry, that the sun is in fact the center of the solar system, right? So the point I'm making in all of this is that when you start looking at all of this, you start seeing that there's the actual apparent truth of what takes place, and then there's a history that's written. And we as students, part of your education, needs to start recognizing this. So for me, the facts are that a 14-year-old boy invented email. And when you start looking at other facts, and I'm going to move a little bit into talking about some of the recent research, when you start looking at the fact that when you start looking at some of the great innovations that came out of India, if you start looking at our medical systems, if you start looking at our agrarian systems, our mathematics, you start finding something very interesting. Now this curve, if you look at it very closely, the left side is the amount of R&D spending that the United States does on drugs, trying to find new medicines. Do you see that curve? It goes up. Can you see it in the back? But what you find is every year that they spend money, what do you find? Less and less new drugs are being found. So the entire U.S. medical pharmaceutical system is not working. The other thing you find, I want you to look at this curve, is everyone heard about the Human Genome Project? Yes? Have you studied that? Okay, you know DNA? We all have DNA, right? So in the mid-90s, one of the big projects was, could we understand how many genes we have? Do you know what a gene is? A gene is a characteristic. There's a gene for blue eyes. There's a gene if you have brown skin. So in the mid-90s, we started sequencing the human genome. Now, you have a human and then you have a worm. Now, who do you think has more genes, a worm or a human? A human? Right, so if you look at this curve, they thought that a human being had about 100,000 genes and a worm had about 20,000 genes. And what ends up happening is when the genome project ends, it turns out we have the same number of genes as a worm. Okay, so us and worms have the same number of genes, so that made people realize, wait a minute, maybe who we are is not the number of genes, and that led to this new field called systems biology. Systems biology said that if you're going to understand the whole human being, which is the right side of that diagram, you could understand the number of organs, the number of proteins, that you could actually sequence this together. Okay, that was a new field called systems biology, which said you cannot just look at a part, you need to look at the whole. And so in 2003, when I came back to MIT to do my PhD, one of the challenges was, could you look at the whole human cell and mathematically model it? You have about 10 trillion cells in your body. Every day, 10 billion cells are created, and 10 billion cells die. But each cell is like a factory, okay? It has thousands of molecular reactions, and the idea was if you could model mathematically the human cell, well, then we could create medicines faster and cheaper without killing animals. Today, they find a drug, then they test it in a test tube, then they kill a bunch of animals. That takes about 6 years, and if that works, then they get the rights to go to human testing. That takes another 9 years. Today, it takes $5 billion and 15 years to create one drug. And then that drug has lots of side effects. This is the Western methodology of creating a drug. So what we did was we actually created a technology which could take those molecular pathways. Anyone take chemistry here? No chemists here? Okay. But if you took chemistry when you were in high school, you would remember, you did, that you have these reactions. So what's happening in biology, those reactions are becoming software programs. And what we did was we found a way to connect these reactions together, and we called this cytosolve. So if email was the electronic version of the human cell, cytosolve is the electronic if email was the electronic version of the office, Cytosol is the electronic version of the human cell. So that's what we did. We wrote many papers on it. And one of the things that happened was, in 2012, Nature wrote this interesting paper on combination drugs. You see, today, if you, unfortunately, knock on wood, no one here gets cancer. If you get cancer, they typically give you a drug, one drug. It's called chemotherapy. But this paper is saying we can't just give one drug, we need to do combinations. Combination therapy. And in fact, we're the only ones cited in there. Now, if you look at this image, which some of you may have seen, in the Indian tradition, the yogi or the siddha, what did he do? Like my grandmother, they would look at you and they would put together combinations of drugs. Curry, for example, is a combination, right? It's manjal, pepper, cardamom, fennel, right? It's a mixture. And the reason our ancient siddhas did this was they knew that if you just give one, it could cause side effects. So you could either give this much haldi, or you could give this much haldi and mix it with the other things. That mixing is called combination therapy. Now, this is part of what we did as Indians long before this article needed to come out in Nature in 2012. We were doing this for 5,000 years. Yeah, you should clap. Yeah. So part of what happened, you see, this is an innovation. The problem is that we forgot what they were doing. We didn't understand the language on what they did. This is an Indian innovation on how they did this. So when the British, as I was speaking to the young school, when the British came to India, they did two things. Not only did they rape our country, but they also changed the history, saying that we weren't innovators. That a guy doing this, oh, he's just in some dhoti, he's just doing something. Right? They had to demean this. You follow what I'm saying? You understand? They had to not only take away stuff from India, but they also had to put down who was an innovator. You couldn't that's an innovator. You had to have glasses, you had to have a collared shirt, you had to look like Isaac Newton, and then you were an innovator. Okay, so they brainwashed all of you. So you think Steve Jobs is the only innovator, right? So you think Isaac Newton's the only innovator, but you would never consider that person an innovator. So what we've done is part of my mission. Remember, I wanted to do what my grandmother did. So what we were able to do now is, with Cytosol, this technology we created, anyone heard of inflammation? Okay, inflammation is a source of most diseases. Inflammation likely causes cancer. What you're seeing here is we looked at 6,000 scientific papers, and we found all the molecular reactions we could find where inflammation is involved relative to manjal or curcumin, haldi. Okay? So this is from the known science where haldi interacts with all those reactions. So we actually have mathematically modeled it, and we can show that when you take haldi, it reduces inflammation. But now remember, you want to do combination. Suppose you want to mix haldi with some grapes. You know, red wine has an active ingredient called resveratrol, which actually is also known to lower inflammation. So what we're able to do is, we're able to be like that siddha, we're mixing haldi with some grapes. Everyone see that? And now what we're able to do, and I want you to follow along, it's very interesting, we're actually able to do mathematical experiments. So if you look at when you have inflammation in your body, there's a certain chemical that's very high. So what you're seeing in this diagram is on the far right. If you look on the far right, the third column, you see 0.15. Everyone see that? 0.15 means you have inflammation. I'm not giving any haldi, I'm not giving any grapes. In the second experiment, you notice I just add haldi. You see it comes down from 0.15 to 0.05. In the third experiment, I just add grapes. It comes down from 0.15 to 0.06. But look what I'm doing in the fourth experiment, which I'm going to highlight. I'm reducing the amount of haldi, or manjal, and I'm reducing the amount of grapes. But what do you see? It goes down to 0.03, even 200% better. This is called a synergistic effect. So our ancient siddhas and our Ayurveda people, they knew how to do combinations. And based on those combinations, they passed that on into our food system. So our traditional food system is actually medicine. This is why Indians, I don't know if you know this, the number one cause of death in all of Asia is liver cancer. Meaning China, India, Indonesia, Malaysia. Indians have 1/3 less liver cancer. And that's because of the manjal and this combination of curry that we eat. So you should be thankful about that. So you don't need to take these. Yeah, you should clap. The point is that our great siddhas were innovating all these formulations from thousands and thousands and thousands of years of innovation. Not killing an animal in a test tube, right? And pushing it through the FDA. Now what we did was no one would believe our stuff worked, so we actually used this technology to mathematically model pancreatic cancer, which is a very deadly disease. We found 2 combinations of Western drugs that did better than one, and this is the formal notice we got from the FDA to go to clinical trials. This is huge, because what we've done is we've shown, and that's cytosol. So bottom line is I feel very fortunate because after so many years, we've actually taken our education, created a Western technology that's validating our Eastern systems. And that we don't need to validate, but if we can do this to all of us who've been brainwashed, we can at least stop the brainwashing to validate what did work, in fact, does work. Now, I want to turn to a different subject, which is related to this, because remember I talked to you about how science can be used to manipulate people, right? Everyone know what GMOs are? How many people know what GMOs are? Wow, only 2 people. Well, you better know what GMOs are after this talk. GMOs are genetically modified foods, genetically engineered organisms. Okay? What is happening in the world right now is that I can take a plant, let's say like brinjal or corn, I can take the genome out of it, and I can insert a new gene into it. So, for example, I could take someone who wants blue eyes, I can insert a gene and give you blue eyes, if I want to, okay? That's called genetic engineering of foods, which are called genetically modified organisms. Now, you know what it is? So, GMO is a genetically modified organism. What's going on in the United States is 94% of the soybeans, 90% of the corn, 90% of the cotton is GMO. The reason that they're doing this is because there's a company called Monsanto which is patenting the seeds. Okay? So they're taking a seed, they do a genetic modification, and then they patent it. And then if you are farmers and you buy my seed, for every seed you buy, you have to pay me a licensing fee. Are you following this? Just like I sell you a piece of software, every seed, I license it to you. So there's a huge concern about this, which means that 1 or 2 companies are going to own every seed that's planted in the world. Now, what does it mean to you? The issue is, okay, that's fine, but does the genetic modification hurt your health? So this is an article in the MIT Technology Review saying, GMOs are absolutely safe. In the United States right now, there's a huge debate. Should you be pro or anti-GMO? In fact, this is an ad, or it's a front page, saying people dancing around a GMO corn. Okay, saying it's great. But then there's other people getting very concerned that GMOs may be bad. So what we did was, when I looked at this as a scientist, I didn't take a pro or anti-GMO debate. We wanted to really find what was going on. So we said, is there a difference, right? If you do a genetic insertion, is there a difference between the tomato on the left and the tomato on the right? Just like, is there a difference between the Hulk and David Banner, right? So the way that they determined this difference is in the 1970s, the United States passed a law called substantial equivalence. What that meant is if you have and it was done for medical products. Let's say you created a medical product, a pacemaker, today, and then a few months later you made some small modification. Maybe you changed the color. But when you did the first pacemaker, it made you take it 7 years to get allowed. When you did the second modification, you didn't want to wait another 7 years, so they said if it was equivalent, it was about the same, then you can get it through. That was done for medical products. So when it came to GMOs, they decided we'll use that same law for genetically modified foods. But remember, a biological organism has hundreds of thousands of parts, not just 10 parts. So this was put into law, and what now happens in the U.S. is if you make a genetic modification, if you say that the apple smells the same, tastes the same, then it's allowed. You don't even have to do testing. Okay? So part of what's going on in India right now is a big GMO manufacturers, they want to bring GMOs into India. Why? Because India has 1.2 billion people. It's a huge market. So there's a lot of propaganda being run about why India needs GMOs. So what we did was we used cytosolve. We wanted to find out, are GMOs different? And if you look on the web, we just published these 4 papers. And what we did was we took soybeans. Anyone eat soybeans here? Okay, India has no GMO soybeans. 94% of soybeans in America are GMO. And Monsanto would love to make all the soybeans in India GMO. And what we did was we looked at soybeans. We went through 6,837 experiments in 184 institutions, and we found out there was a major difference. We found out that GMO has formaldehyde. Everyone know what formaldehyde is? And it depletes glutathione. Glutathione is a very nutritious thing, and what we found was on the left curve, in the non-GMO, formaldehyde is produced and is detoxified to near zero levels. On the right side, you see formaldehyde accumulates. You see the difference? Can everyone see it back there? So there's a big difference. Meanwhile, the propaganda is there is no difference. And the same thing here. Glutathione levels are normal, and then in the GMO they drop. So what I'm trying to say is, here's an example of where we've used the technology to help uncover something that the media in the U.S. is confusing people on. Fortunately, in India, the scientists so far are very smart about introducing GMOs. The last thing I want to talk to you about is, this is what systems biology is. Okay? The Western world understands a human body by genes, molecules, protein. Now, our Siddhas had a very different way of looking at the world. So this is this pyramid, which is the West, this is the right. How many people know what Siddha and Ayurveda are? Anyone? Few people. Okay, more people. But if you study Siddha and Ayurveda, they have a whole language. They say the world was created by, there was nothingness, which is Purusha, that gave rise to Prakriti, which gave rise to the Gunas, which then gave rise to the Panchabhutas, which were the metals, 5 elements, which then gave rise to the Tridoshas, which are essentially Vata, Pitta, and Kapha. And then those gave rise to the tissues, which gave rise to the human body. Now, when we start learning Western science, we look at these words and we think, oh, this is just, this is like some nonsense they wrote. And in fact, when an Ayurvedic physician looks at you, they look at your body, they may look at your face, they may read your nadi, and then they decide which dosha are you. Vata or Pitta, Vata, Pitta, Kapha, right? And based on that, then they decide how you've unbalanced yourself from there, and they decide what are the right foods you need, what are the right supplements, what are the right exercises. You see, it was a very powerful system, but if you look at this, you think it's just some words. So when I came back on my Fulbright in 2007, that's again